complete the square.
So in math, chances are that I'll probably run into something called a quadratic equation, which looks like this. Where the value of a is a number besides 0. In a case like this, we're solving for the value of x because variables a, b, and c have already been assigned values. There's many ways to solve these kind of equations where a is a value other than an understood one. Most people use something called a quadratic formula, which is this. Now, this is a formula where you can just take the values of a, b, and c and plug them into the formula and evaluate to determine the value of x. But have you ever wondered where exactly this formula originated from? That's when completing the square becomes a useful method. Completing the square has to have the quadratic equation rearranged in a way where the value of a has to be an understood one, which causes a equation to look somewhat like this. Which is beneficial for the next few steps. So, to get rid of the a value if it isn't an understood one yet, you'll have to divide the entire equation by a because the number of any value other than 0 divided by itself would be just 1. Note if the value of a was 0, 0 multiplied by anything is 0, so then the equation would just be an R-squared equation. Moving on with our equation, the equation should look like this. Note that 0 stays as a 0 because 0 divided by anything would still be a 0. In order to remove a square, we have to square root it. But if we square root it now, it would be such a tedious task to get to the value of x. So instead of square rooting the entire equation now, we should find a perfect square that covers x to the second power b over ax. So when we square root the entire equation, it would be less messy. So first, we have to get all the values we need for a square on the same side. In order to achieve that, we have to subtract c over a to get rid of c over a. And everything we do to one side, we have to do to the other side. So we end up with this equation. When we're given a perfect square binomial, or something that looks like this, when we then evaluate, we're left with this. So if we do the reverse and start with this, we can put that in a form of a first square binomial like this, which is a form that can easily be square rooted because a square cancels out a square root, and the square root of that binomial would simply be this. So if we apply that with terms for our equation, which we so far have, these terms will act as x to the second power y squared from our perfect square example. So now we need to find a value of the y to the second power of our equation to complete our perfect square. There is a formula to find the value of that, which is this. In our equation, the b from the formula would equal b over a because of our a value. And if we simplify that, it becomes this. So y squared would just be this. Which we can add to our equation. But we didn't have a value of b over 2a squared in our equation to start with, and we didn't simplify or expand anything to get it. We just came up with it ourselves. So because of that, we have to add it to our equation first if we want to do anything with it. So if we add anything to the left side, we have to add to the right side as well. So then we end up with this equation. Now remember, why did we need to add b over 2a squared? Because it completes a perfect square. So now we need to simplify the square into a form like this. Note that b over 2a is y because of square rooting. So now our equation would look like this. Now we want to simplify the right side. So in order to add negative c over a and b over 2a squared, we have to find a common denominator, which means that first we need to simplify the square b over 2a squared, which would be this. And to get from a to 4a squared, we need to multiply a by 4a. And so if we multiply the bottom of negative c over a by 4a, we need to multiply the top two. So that will just be multiplied by 1, which keeps the value equal. So now our equation should look somewhat like this. And now we simplify the right, which should give us this. So now we square root the entire equation, which gives us this. And for our last step, we isolate x by subtracting b over 2a from both sides, which leaves us with this. Now that we got our answer, it kind of looks like the quadratic formula from earlier, right? So now we see that completing the square and the quadratic formula are the same thing. We could use completing the square to solve a quadratic equation. So let's try this formula on our equation. 4x squared minus 8x minus 32 equals 0. First of all, we divide the entire equation by the a value, which in this case is 4. After we divide the entire equation by 4, it should look somewhat like this. And now for our second step, we add 8 to both our sides of the equation. Which gives us a result of this. So then to complete our square from the left side, we need to add b over 2a squared, which for us right now would be negative 8 over 2 times 4 squared, which would be equal to 1. And if we add that to our equation, it would look like this. Now if we simplify both sides, it would give us this. And if we square root everything, it would give us this. And if we simplify 9 square root into 3, we get this equation. And now to isolate the x, we add 1 to both sides. And 1 plus or minus 3 is equal to 4 and negative 2. So that means that x is equal to 4 and negative 2. And that's how we complete the square.
Alright, and any questions? Yes?
Why would someone want to know how to complete the square if we can just learn the quadratic formula?
Great question.
So first, in order to get the quadratic formula, we have to know how and why it works, which would be because of completing the square. And secondly, later on in math, there will be some cases where we just need an equation from a step in the middle of completing the square. We can easily just take out that portion, but if we immediately jump to the x solution with the quadratic formula, we'll have a hard time figuring out what equations the formula combined to get the solution. There's many other reasons why someone would prefer completing the square instead of quadratic formula, but the quadratic formula can still be very useful and faster if we just need the x solutions. But the biggest reason why someone would prefer completing the square instead of the quadratic formula is because it's W.